6-2, we're still looking at bisectors or perpendicular bisectors and angle bisectors, but here we're looking at them in a triangle. Our first term is concurrent. Okay? Concurrent is things that happen at the same time. Right? So our class and another class that occurred during the same period are classes that are occurring concurrently. In this case, when three or more lines, rays, or segments intersect at the same point, they are called concurrent, which is what our definition says. So I'm looking for one point that shares three lines, rays, or segments. So it's where they're intersecting. That point where the three lines meet is the point of concurrency. Right? So the lines are concurrent, the point is the point of concurrency. So the point of the intersection of concurrent lines, rays, or segments is called the point of concurrency. For our triangles, we have several different points of concurrency based on the type of lines that meet, and we have different names for them. What we're looking at today is the circumcenter, which is the first thing, and the incenter, which is the second thing. The circumcenter is the point where your perpendicular bisectors of a triangle intersect. So these are lines that go through the line, hit it at 90 degrees, and cut it in half, our definition of perpendicular bisectors. That point, the circumcenter, is the same distance from all the vertices. So when we looked at the first if there, if PD, PE, and PF are perpendicular bisectors. Those three lines are perpendicular bisectors. They're hitting at 90 degrees and cutting the lines in half. What I then know is that point P is the same distance from all three vertices. So BP, CP, and AP are all congruent. Those blue lines are all equal. Okay? The segments on the outside are cut in half by the perpendicular bisector. This lets me solve a couple things. So when we're looking at the next problem, it asks us for BG and AC. AC is on the outside. So the line that hits in the middle of it cuts it in half. So AC is 16 based on that 8. BG, though, is going from the center to an angle. That is the same length as these other lines that do that because G is a circumcenter. So this line is 9 based on CG. We then have the incenter. The incenter is where our angle bisectors meet. So here, AP BP and CP, those are our angle bisectors. Unlike the picture above, even though it looks similar, those lines are not the same length. That point, your in-center, is the same distance from all three sides. Distance to a side from a point has to hit at 90 degrees, which is why you see the 90-degree marking there. So, PF, PE, and PD are all congruent. So it's PD congruent to PE congruent to PF, based on point P being our in-center. I'm only going to show one of these three problems. This is showing that these problems can get complicated because they do have the 90 degrees. So in some cases, they use a right triangle. So when I'm looking up here, they're asking me for LK. LK is that line. But that line is equal to this line and this line. If I had that, I could just solve for it. I don't. So what I need to use is the right triangle. So we are looking at that green right triangle to solve. Our setup would then be 12 squared plus x squared equals 15 squared. 144. Make sure you square first. You want to square before you start solving. So I have 114 plus x squared equals 225. Subtract the 144. Right? 81. All right, take the square root of the x squared. X is equal to 9. Some of those problems, you will just have them where they're equal. This would be a complicated version of those. And example 4 and 5 are similar to that. Right? So we are just going to show example 3 for right now.